We'll work on the practice. All right, what is the mass of an iron wrecking ball that has a radius of 18 centimeters? And I gave you the equation for volume of a sphere, and I gave you the density of iron. So, first things first, density equals mass over volume. Remember that the funky-looking P-ish thing is density. Yep. They're like, hey, you know what looks a lot like density? P. Well, and the Greek letter rho is close to R, so even that doesn't make any sense. The Greek letter D is delta. So, there you go. So, it's omega. I'm more of a psi kind of guy myself. So, plug in what we know. We know the density of iron, 7.8 times 10 to the third. You can write that as 7,800 if you'd like, because that's all 10 to the third is. It's just multiplied by 1,000. Okay? So that's equal to mass over volume. And volume is 4/3 pi r cubed. So 4/3 pi r cubed. Now, the radius needs to be in meters. It is not, so we need to convert it into meters. So to convert centimeters to meters, you divide by 100, which is moving the decimal back twice. So 0.18 cubed. So grab your calculators or borrow one from me. So all you got to do to solve is figure out what you got on the bottom and then multiply that to the other side. So 4/3 times pi. I don't know if this one has a pi on it or not. It does. Times 0.18 to the third power. Let's do 0.18 to the third first. Let's multiply that by pi. Multiply that by 4/3. Okay, so we get the volume to be 0.024. Just a friendly neighborhood advice. You are generally going to think the volume is too small. Generally, the volume will seem really, really small to you. And that's because the unit is cubic meters. Okay, it's cubic meters. A cubic meter is a huge amount of stuff. Okay, 1 cubic meter is like from the top of the desk to the floor and then both sides of the desk. That's too small. Like the whole desk underneath of it is not quite a cubic meter. So cubic meter is pretty large. So this is 0.024 cubic meters. We're going to multiply that number to both sides. 7.8 times 10 to the third equals m over 0.024. Multiply that number to both sides. And we get mass equals 190.5. That's fine. You probably rounded, or I rounded. Somebody rounded. What is pressure? So pressure. It's how much force you push over an area. So it's force applied to an object over an area. So pressure is a little bit more realistic than force. See, force is just how much is applied, and that's because we generally assume objects are super tiny, small point objects, which is not a perfect analysis, but it works for our purposes. Pressure is a little bit more accurate because it's specifically talking about how that force is spread out. Just like momentum is a little bit better of an idea when you're talking about collisions because it's how the force is spread out over time. This is how the force is spread out over area. The unit is pascals. What? I'm going to be honest, I don't actually know how to spell it.
Yeah, the lizard.
A lizard? Is a lizard named Pascal? And the unit is pressure equals force over area. This one is all the letters are exactly what you think they are.
Why would they have P for pressure and then the one that looks like P for density?
Yep.
That's a big Brady physics stuff right there.
Yeah.
And P for moment.
What is with you and momentum? I keep hearing him say momentum.
Velocity.
All right, so let's do an example here. So 1 foot of a 60 kilogram person covers an area of 250 centimeters squared. Remember that Fg equals mg. A, what is the pressure exerted if the person stands on 1 foot? What's the pressure exerted if they stand on 2 feet? So pressure equals force over area. So what is the force? Well, the force is the weight pulling down on the person. So the weight that they have pushes down on the ground, and that's the force. So all you have to do for F is mg. So mass is 60, g is 9.8. Over the area. And I gave you the area. You didn't have to calculate it. I gave you the area. It's 250 cubic centimeters. Sorry, square centimeters. 250 square centimeters. Here's the problem, though.
It's in bold.
It can't, yeah, it's in bold. It can't be in centimeters. So we got to convert. Well, that's easy enough. We know that you divide by 100 to turn centimeters into meters. So you would divide and move backwards 2. Except that's not the right answer because it's centimeters squared. You got to divide by 100 twice. Yep. So it's 0.0250. So we move from centimeters to meters twice. Okay? And that's because it's centimeters squared.
It's centimeters times centimeters.
Yep. And all you got to do now is 60 times 9.8. Divide by 0.025. Yep. So remember how I said volume is going to feel small to you? Pascals are going to feel big to you. Okay, so what if I stand on 2 feet? Well, if I stand on 2 feet, it's going to be the same setup for starters. mg for the force. The area of 1 foot is 250, so 0.025. But it's not 1 foot, is it? It's 2 feet. So you just multiply by 2. Yes, so I was going to talk about that. So the answer you get is 11,760. There is another way to do this simpler. And the way to do that is to divide your first answer by 2. Why would I do that? Why would I divide my answer in half? Yes, so it's spread out over double the amount. So you would cut it in half that way. Okay? If you were on 2 feet and you stood off of one onto 1 foot, then you would double it to make it more pressure. Okay? Here's the only assignment for next time. The only assignment for next time is finish practice 1. So do it now. Do it now. Get her done. You got 5 minutes. You can do it. I have faith in all of y'all. There's no back. No back. All you got to do is set up for the pressure. Now, you do need to make a change. Change the area of leg to be 4 square centimeters, not 0.02. I don't know where the 0.02 came from. It should be 4. If you do 0.02, you're going to get a ludicrous answer. Yep. Point oh oh oh. Point oh oh oh. Point oh 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 4. Point oh oh 4. Oh oh 4. So it's 4 over. Yeah.
Sweet. How much better do I?
You don't remember that?
I didn't take your vote. You took my vote. I think you did.
I took
Yes.
Yeah, and then this down here. I weigh 60 kilos.
This would be, so yes, times 4. Yeah, be careful with a couple of things. First of all, you got to include the mass of Ben and the mass of the chair. Secondly, it's 4 legs, and the area I gave you is just for 1. So make sure to include all 4.
$60 times 10 and then again by
60 times then, and then a 10, and then again by 9.8. Yes, sir. Did you include the 4? You did. No, so then this is 1. So you would multiply this by, so this amount times 4, or divide that by 4, because it's spread out.
Mine gives me an answer. But I understand. $3 million.
So it needs to be 70 times.
Anybody else? I think. What'd you get? Wait, what'd you get from D?
Because it goes from 4 legs to 6
Yeah, but
So you just times 8.
So let's just second guess.
this is just my chair. You gotta include them also. And this is 1 leg.
That then should be standing.
Okay.
For me, would you just multiply by 6 and
Yes. Yes. Because it's more pressure. Give me my calculators back. Don't keep them. Don't be that guy. Or girl.
Yeah, you're not that guy.
Don't be that girl either, Noah.
Trust me, you're not that guy. You are not that guy. Trust me, you're not that guy. You're that guy. If you're on one, it's going to be like a new. That's not an
Ooh. Almost.